Ross 128b. Ross 128b quietly sits among the most promising potentially habitable worlds ever discovered, yet it rarely receives the attention given to more famous planets. Located about 11 light-years away, it orbits the calm, red dwarf star Ross 128. Unlike many red dwarfs that frequently unleash powerful stellar flares, Ross 128 is unusually quiet, reducing the amount of harmful radiation reaching the planet. Ross 128b receives only slightly more energy than Earth receives from the Sun, placing it near the habitable zone where liquid water could potentially exist. Scientists estimate the planet is roughly 1.4 times the mass of Earth, making it a rocky super-Earth rather than a gas giant. One intriguing possibility is that the planet may be tidally locked, with one side permanently facing its star. If an atmosphere exists, winds and ocean currents could redistribute heat, creating a stable region between the day and night sides. Its combination of proximity, relative calmness, and Earth-like characteristics makes it one of the most overlooked candidates for future habitability studies. LUYTEN b. LUYTEN b orbits LUYTEN's star, approximately 12 light-years from Earth, and has become increasingly interesting to astrobiologists. The planet is believed to be around 3 times more massive than Earth and receives about 65% of the sunlight Earth receives. That places it comfortably within the star's habitable zone. What makes LUYTEN b particularly fascinating is the possibility that it could maintain temperatures suitable for liquid water if it possesses a sufficiently thick atmosphere. In 2017, the planet attracted public attention when a messaging project transmitted a collection of radio signals toward the system, making it one of the few exoplanets to receive a deliberate communication attempt from humanity. Because its host star is relatively stable compared to many red dwarfs, the environment may be less hostile than scientists once assumed. Climate simulations suggest that even if the planet is tidally locked, large portions of its surface could remain temperate. It remains one of the nearest potentially habitable worlds known today. K2-18b. K2-18b has become one of the most debated planets in modern astronomy, because it may represent an entirely new type of habitable environment. Located about 120 light-years away, it orbits within the habitable zone of a red dwarf star. Unlike Earth, K2-18b is much larger, containing roughly 8 times Earth's mass. In recent years, observations from James Webb Space Telescope detected atmospheric compounds including water vapor, methane, and carbon dioxide. These discoveries sparked interest in the possibility that the planet belongs to a proposed class called Hycean worlds, planets with vast global oceans beneath hydrogen-rich atmospheres. If that model is correct, life could potentially survive in environments very different from those found on Earth. The planet's size means it is unlikely to possess a solid surface like our own world, yet habitable conditions could still exist within its oceans. TEEGARDEN'S STAR b. TEEGARDEN'S STAR b orbits one of the closest stars to the solar system, yet it remains surprisingly unknown outside astronomy circles. The planet circles TEEGARDEN'S star roughly 12.5 light-years away and receives nearly the same amount of stellar energy as Earth. Its estimated mass is very close to Earth's, making it one of the most Earth-like planets discovered in terms of size and irradiation. Because TEEGARDEN'S star is extremely faint, the habitable zone lies much closer to the star than Earth lies to the Sun. This raises the possibility of tidal locking, but climate models suggest a sufficiently dense atmosphere could still maintain habitable temperatures across much of the surface. The host star is also relatively old, meaning any planetary environments have had billions of years to evolve. Some habitability indexes rank TEEGARDEN'S star b among the highest-scoring exoplanets ever discovered. Despite these impressive characteristics, it receives only a fraction of the attention given to more famous candidates. TOI 700d. TOI 700d became a milestone discovery because it was the first Earth-sized habitable zone planet found by transiting exoplanet survey satellite. Located about 100 light-years away, the planet orbits a small red dwarf star and receives roughly 86% of the energy Earth receives from the Sun. Its size is remarkably close to Earth's, increasing the likelihood that it is a rocky world rather than a gas-rich planet. Scientists created numerous climate simulations to explore possible conditions on its surface. Some models showed oceans, clouds, and stable temperatures capable of supporting liquid water. The star itself is relatively quiet compared to many red dwarfs, reducing concerns about intense stellar radiation stripping away an atmosphere. Because the planet transits across its star from Earth's perspective, astronomers can continue studying it in detail using future telescopes. Wolf 1069b. Wolf 1069b quickly gained attention among researchers after its discovery because of its remarkable similarity to Earth in several key areas. Orbiting Wolf 1069 about 31 light-years away, the planet has an estimated mass only slightly greater than Earth's. It receives around 65% of the stellar energy Earth receives, placing it firmly within the habitable zone. Scientists estimate there is a significant possibility that the planet possesses a rocky composition and could retain an atmosphere. Even if it is tidally locked, climate models indicate that liquid water might survive across large regions of the illuminated hemisphere. atmosphere. One interesting aspect is that Wolf 1069 is considerably less active than many comparable red dwarf stars, reducing the likelihood of destructive flare events. This stability could improve the long-term chances for habitability. Although discovered recently, Wolf 1069b immediately joined the shortlist of nearby exoplanets that future observatories may examine for signs of atmospheric chemistry associated with life. LHS 1140b. LHS 1140b is often considered one of the strongest candidates for long-term habitability ever discovered. Located around 48 light-years from Earth, it orbits within the habitable zone of the red dwarf, LHS 1140. The planet is significantly larger and more massive than Earth, which may help it retain a thick atmosphere over billions of years. Observations suggest it could contain large amounts of water and may even possess a global ocean beneath its atmosphere. Unlike many red dwarfs, LHS 1140 appears relatively stable, reducing exposure to extreme radiation. Recent studies have proposed that the planet could be an ocean world with conditions potentially favorable for life. Its density indicates a substantial rocky component rather than a gas-dominated structure. Because the system is comparatively close to Earth and aligned favorably for atmospheric observations, astronomers view LHS 1140b as one of the most important targets in the search for biosignatures beyond the solar system. KOI 5715.01. KOI 5715.01 remains one of the lesser-known worlds identified through data from Kepler Space Telescope. What makes this candidate intriguing is its Earth-like orbital characteristics and its location within the habitable zone of its host star. Preliminary measurements suggest that the planet may receive a similar amount of stellar energy to Earth, an important requirement for maintaining surface liquid water, because it remains a candidate rather than one of the most extensively studied confirmed planets. Many details about its atmosphere, composition, and environment are still uncertain. Nevertheless, statistical analyses place it among the more promising Earth-sized, habitable zone objects identified by the Kepler mission. Thousands of exoplanets have been discovered, but only a small fraction occupy the narrow region around their stars where temperatures might allow liquid water to persist. KOI 5715.01 demonstrates how many potentially habitable worlds may still be hiding within existing datasets, waiting for future instruments to reveal their true nature.